Yes, ma'am. Am I audible to you? Please open the camera. Okay, Memuna, in the last class, we started with phases and phasor diagrams, and I think one circuit we have completed or we didn't start. Hmm?
We did AC circuit containing only resistor.
Containing only resistors we have completed, no, this part. Yeah.
Ma'am, they have
What?
the school teacher has changed the portion again. Now we have current,
Now what do you have?
AC current and EMI.
Okay. So let's continue with this, and EMI is already there. Just tell me the date, Memuna.
28th October.
28th October. Just give me a minute.
Okay.
So, see, basically in the AC circuits having only resistor, what all things you need to know and what all things are important. So, firstly, that you should understand is when you do this in derivation, I is equal to I naught sine omega t you're getting, and E is equal to E naught sine omega t. So, this shows that both of them are in the same phase because you cannot see extra angle anywhere. This is exactly I naught sine omega t. That is it's exactly as E naught sine omega t. You cannot see plus 30 degree, plus 20 degree, minus 20 degree, which can show you that yes, other angles are also present. Okay. And they are in the same phase. That also we had started. Now AC circuits containing only inductors. These we have to complete. AC circuits having only inductors. So see, E is equal to E naught sine omega t, and E is equal to minus L di over dt. This is a part of EMI. So after this chapter, we will do EMI. And at that time, you will understand what is E is equal to L di over dt. But I'll just tell you, it basically is a portion from your inductance. Okay. So right now, you can just understand E is equal to minus L di over dt. Let us put the value of E. So this will be E naught sine omega t is equal to minus L di over dt. Okay. So E naught sine omega t is equal to minus L di over dt. This is dt. So what we are going to do, we are going to keep I on one side and rest of the terms on other side. So when you have di, this is E naught by L sine omega t dt integral here. Okay, sine omega t dt. Now we have to integrate it further. Zara, we are basically doing the circuit having only we will become cos omega t by omega t. So I think I told you earlier, as I have told you that learn these things. One more thing, class, this L is also present. I was about to. E naught is there, L is there, sine omega t integral becomes cos omega t by t. One or two things, see class, when you are using this chapter, solving this chapter, if you get, it is sine 90 minus theta, because it's a very common identity that you can meet anywhere. And other is if you have minus of sine theta, then this is equal to sine minus of theta, like this. So these are the two identities further also, which can be helpful, but these are usually employed in the derivation. So as a part of derivation, I will suggest that just remember them and remember these properly. So what do we have? I is equal to minus E naught cos omega t divided by omega L. Zara, please open the camera. Now let's write every term together. See, minus E naught divided by omega L. Okay. Minus E naught divided by omega L. Cos omega t divided by omega, I have told you earlier. Now the equation that you get here, what is this? This is cos theta. If you just look at it as cos omega t, basically your omega t is theta. If a wave is flowing and another wave is flowing like this. So this, can you see some angle is there, which we usually represent with phi, theta, like this. So this is cos omega t is present. So best method is that the identity which I have told you, cos theta is equal to sine 90 minus theta. What is our theta here? Omega t. Rest of the constants I have just put it aside. I am left with cos omega t. So how can I write cos omega t? Minus E naught divided by omega L has been kept aside. So this is basically cos omega t. So cos omega t, according to the identity, this identity which I have told you, you can write this as sine 90. 90 means pi by 2 minus theta. What was theta? Theta was omega t, which we were replacing. Right? Now look, if you compare this, I'm writing it properly. If you are going to compare this with the identity, yeah, here I'm writing. So I is equal to I naught sine. One thing we can do is that to remove this minus sign, we can shift this. See, when you have minus sign outside the brackets, if you multiply it with minus 1, the symbols or the quantities present within the bracket, they will be interchanged. If I want to put minus 1 back, then I'll have to interchange it again. So this is minus E naught by omega. So I want to make this plus. So let me just change this. Let me make this omega t minus pi by 2. But why? And not I naught, sorry, E naught by omega. This is E naught by omega L. Minus sign has been shifted. I have interchanged the bracket. So that's why this minus sign has gone. Now, what was the identity which I told you initially? I is equal to I naught sine omega t plus phi. Plus phi, you can hear in this case it is minus phi. So minus phi. Just compare. Current is this. I naught is E naught by omega L. Sine is sine omega t same, and this is the phase difference. So what do you understand from here? I is equal to I naught sine omega t. When we say, basically you should understand this, that current is having minus pi by 2. Minus means something which is lagging behind. Plus means something which is getting added, something additional, something in advance. But look at your equation. Equation is I is equal to I naught omega L sine omega t minus pi by 2. And if you compare it with the main identity, I is equal to I naught sine omega t minus phi, it clearly tells us that I naught is equal to E naught by omega L. First thing, these two should be the same. Secondly, the phase angle. These two are very important to extract out. These two are very same. Means the current is lagging. If we were getting current, here we were getting plus symbol, then it means the current was ahead. Okay. So rest of the things we'll continue later. First, you write it here, both of you, because then it will be a lot length. Write it first. Should we proceed further?
Yes, ma'am. Done.
Okay. One thing I wanted to ask. Yeah, Memuna, you have told me that AC and EMI are coming. Same with Zara, because I think you both are in the same school.
Yes, ma'am.
Okay, then. So see, you have to prepare for the test as well. So just tell me the date.
20 October.
20th, 2020.
Yeah, UT.
The internet is unstable. Just my voice, is it better? Okay. So for 20th October, then I'll be preparing you these two chapters, AC and MI. So a class, we might need some extra classes also, because you know the time is very less. Already it is the first week of October has gone, so very less time is left. Okay, so we need extra classes. So just be prepared for that. And in those because see, I don't want to rush up with anything, because this exam is not the end. You have your board exams also. So we have to study in a manner that your this exam also will be benefited and your upcoming board exam will also be benefited. Right? So just be prepared for some extra classes and please revise it on a regular basis. Take these classes as if you're revising directly for the test only. You don't have the purpose of boards or anything. Just focus on this class test. Because let us see what kind of paper comes. Let us practice the questions. Let us see. Okay. So here, when minus phi is coming, this means what I was telling you, that this is basically saying that current lags by pi by 2. Current lags by pi by 2 means EMF is leading by 90 degrees. Both the waves are drawn, current is lagging behind and EMF is ahead. And when you calculate the angle between them, the angle is pi by 2. What is meant by pi by 2? Which angle is this? What is the value in degrees? 90 degree. Correct. This is simply 90 degrees. Okay, so this point should be remembered by you. Now coming to that denominator XL, see, I wrote I naught is equal to E naught by omega L. Remember, here I have told you that I naught is equal to E naught by omega L. This is equal to E naught by omega L. So if we talk about this E naught by omega L, class, this omega into L is basically called as XL. XL is the inductive reactance. See, every circuit has a current, every circuit has a voltage, every circuit will be having a resistance. When we talk about the normal circuits, DC circuits, you know there's a resistor present to oppose the flow of electrons, right? When we were talking about the circuit having only resistor, that time also we had seen that only resistor was present and the resistance was R, the voltage was V and the current was I, like this. So if we are talking about the circuits having only inductors, there should be some resistance for that circuit. You cannot use R because R is the resistance. R is the resistance for the circuit having only resistor. So we need to use some other symbol. That other symbol is X with a subscript L. This not exactly a subscript, but yeah, you do not write it completely. XL. XL is basically the resistance of the circuit having only inductor. Omega is what? Angular frequency. L is the inductance. L and everything we will start though if I knew that your syllabus would have been EMI and AC, I would have preferred to start with EMI chapter. But we have to go reverse now because we cannot leave this in the middle. So omega L is basically inductance. Just have an idea about it, or I'll tell you this later in detail. Just remember omega into L, this is equal to XL. And XL is basically the resistance of the circuit. You can look by the formula also. See, according to Ohm's law we have studied I is equal to V by R. Means I naught is representing the current. Voltage is being represented by E naught. Resistance is being represented by omega L. So what is omega L? Omega L is equal to XL. This is the formula for it. Okay. Now class, sometimes omega, in the last class I remember Zara was answering 2 pi nu. Remember this? Omega is equal to 2 pi nu. So sometimes we can use 2 pi nu L is equal to XL. What is nu? Linear frequency. This is the linear frequency. Okay. So I is equal to E naught by omega L. I is equal to V by R. Omega L is equal to XL. 2 pi nu is equal to 2 pi nu L is equal to XL, which is the linear frequency. Omega is the angular frequency. This is the angular frequency. If you look at the definition is same as that of the circuit of having a resistor as the resistance. Same thing. If an inductor is present and you have a proper circuit present, so will you not have any resistance? You will definitely have a resistance, correct? So this should be very clear. Few things I am repeating. Please understand them, and if you have doubts, please ask me again. Because the initial portion which we have done about AC dynamo, you'll be able to manage that. This part is very important, and you have your exams. In the next class, I'll be asking you questions also from whatever we have done, so that you are revising continuously. First thing, when you have a circuit having only resistor, current and voltage both are in the same phase. As you can see both the equations. I is equal to I naught sine omega t. E is equal to E naught sine omega t. No angle is present which is differentiating between the different phases, because there is no different phase. Both are in the same phase. You know the formula. I is equal to I naught is equal to E naught by R. IRMS is equal to ERMS by R. All this. Okay. Basics we have done. Second, inductor, circuit having only inductor. When we are talking about this, the voltage is E naught, current is I naught, everything is same, but here the resistance is not R. Because in your circuit, you don't have a resistor, you have an inductor. If you have an inductor, that circuit having only inductor will be having its own resistance, which we call as XL. XL's formula is XL is equal to omega L, because we have seen it in the denominator, it was similar. XL is equal to omega L, which you can further write as 2 pi nu L. Tell me both of you properly. Is it clear?
Yes, ma'am.
Okay. Now, few things are there in this. If XL is equal to 2 pi nu L. This is the formula which I have told you. Let's start with you, Memuna. Memuna, you tell me, how are XL and L related to each other?
XL is the
Related as in through the formula. Like if I have to plot the graph, what is the first thing that I should check? Directly proportional, inversely proportional,
proportional.
directly proportional. See, this and this, they are directly proportional. XL is directly proportional to L. See class, if here now the IRMS in this circuit, it will be VRMS, ERMS, whatever is given, divided by XL. This is the resistance. So if the resistance is very less, Zara, you tell me what will happen to the current if resistance is very less, XL is very less. What will happen to the
Current
current?
will be more.
Yeah?
Current will be more.
Current will be?
More.
More. Yeah, current will be more. Correct. Current will be more because there is no opposition to the flow of electrons. So if I make this XL completely equal to 0, so we say it means the current will be the maximum here. See, if current is, if I say in this equation, IRMS is equal to VRMS divided by XL, if I say this is 0, it means this with this whole term will be infinite. You know, 1 by 0 is equal to infinity. Current will be so much, that it will be infinite because we have reduced resistance to the minimum value. See, we could have made it negative, but we know resistance can never be negative. Negative resistance has no physical significance. So that's why the lowest possible value for a resistor is 0. So if you get that condition, you will get infinite current, lots and lots of current you will get. But actually, this is not possible. You can never have zero resistance in any circuit. Some amount of resistance will be present that can be controlled, but that cannot be controlled, depends upon the circuit. But you cannot directly say that, yes, this is existing. So when it is existing, when when you have something very perfect, and you know it's not existing, so what's the word that we use? Ideal. This is ideal. The course was ideal for me. If I had a course in which this is done, that course is ideal for me. We use the term ideal a lot, right? Means something which is perfect but it is not existing. Usually we say it like this, or it can exist but it's rare, something like this. So same thing here. Least resistance like XL. XL means the resistance. A wire where a current is flowing, electrons are flowing, and there is no opposition to the movement. This is actually not possible. But if it is possible, then we say this is the case of ideal inductor. Means in our circuit, lots and lots and lots of current will be there. Like, see, it's like you say, I want a job where I do no work and I just get money. So that's an ideal job, right? We say that's an ideal job for us, but you know it can never exist. You have to work. So it's something like this. XL is equal to 0. That we want this year. Yeah, that yes, we'll get lots and lots of amount of current in our circuit. And resistance also, there will be no opposition in the wires, and the current will smoothly flow and we'll have lots of current. But you know, that's an ideal situation which cannot exist. So ideal inductor, this is the case. So these things you have to remember. And as Mamuna answered that XL is directly proportional to L, or XL is directly proportional to linear frequency also. Or if you use the formula XL is equal to omega L, XL is directly proportional to omega also. Class, if you get a graph to plot between any of these three, XL is constant, but linear frequency, inductance, angular frequency, any of these variable is there, it will be a straight line graph, means linearly proportional. What is XL? Inductive reactance. This is inductive reactance. Okay? Inductive reactance. And what is this? What is this? This is frequency. Tell me, this part is clear? Okay. Last part from this. See, when you have a circuit to represent it in phasor form, the last thing is this. See, EMF is already at higher point when the current has just begun to move. Current is at 0. And see, EMF is so high. Means, what is this angle between them? 90 degree. We say EMF leads the current by 90 degree. Look, there's a gapping in the wave. This wasn't the diagram in the resistor circuit. And see, both were overlapping in the resistor circuit because it was in the same phase. Now, since EMF is ahead, so we have drawn the current behind in the fourth quadrant to show that, yes, it is lagging behind by 90 degrees. So these are the two. This is the graph. This is the phasor diagram for this. Write it, understand this. Any queries? Then you can ask. Start writing from here. Done?
Yes, ma'am. Yes, ma'am.
Okay, AC circuit containing only capacitor. This is the last of the individual circuits. So resistor done, inductor done, then now the third one is the circuit having only a capacitor. So E is equal to E naught sine omega t. So what is the potential here? Potential is E, which is equal to E naught sine omega t. Now tell me a formula, Zara, which relates charge and potential.
E is equal to V by
Q is equal to? Yeah,
I
Q
was
is
saying,
equal to?
yeah, I was saying something else. Uh,
I want a relationship between what is the formula for capacitance?
uh, epsilon naught A by T.
In terms of potential and charge.
There's like E is equal to C into V.
E is equal to
C into V.
this.
Yes, ma'am.
What is E? What is V?
V is like potential and E is like charge. Elect.
So for charge, we never use E. E, capital E is represented for electric field. Q is equal to CV. This is your Q here.
Oh,
Okay.
okay, ma'am.
Never use E for the charge. E is small e specifically for electron. We are talking general. So yes, Q is equal to CV. Okay, Q is equal to CV is the formula. So I should put the value of EMF here. Q is equal to C. And what is V? E naught sine omega t. See, current, formula of current. Yes, Memuna. In terms of charge, what is the formula of current?
Q by
Q by?
R. No, Q by I.
This.
Yes.
Okay, if this is it. Then I is equal to V by R is what? This is wrong. Is this wrong? Second one.
No, the second one is right.
Okay, second one is right. But I don't have charge here. I want the formula of current in terms of charge. What is the definition of charge? Memona, you have done current electricity with me. So we know that we have done it together, right? The chapter current electricity has been done. It's over. So what is the basic formula of current? What's the definition of current? What is the basic formula?
Q is equal to IR.
Yeah, Memona, you're saying something?
Q is equal to IR.
Q is equal to IR. V is equal to IR is not existing. Why are you making the formula as Q is equal to IR, that you're writing Q is equal, I is equal to Q by R, Q is equal to IR. The formula is V is equal to IR, which is Ohm's law. It means I have to take your test on current electricity also. You people have not revised it at all. Firstly, this is Ohm's law. Secondly, I want the formula of current in terms of charge. Charge makes up the current in the circuit. What's the basic formula? We have done so advanced formula. We had seen two cases also where average was calculated, instantaneous was calculated. I'm just asking the basic formula. No. Zara, do you know the answer?
I is equal to Q by T.
I is equal to Q by T, Memuna. What is the definition of current? Rate of flow of charges. I specifically told you that rate means something which is changing with respect to time. We had done two cases also where duration, if duration was given, we used to calculate the average. If the instant was given, we used to calculate the instantaneous one. Please revise. Please see, Ohm's law is very basic. Current's formula is very basic. Current electricity is already very basic chapter. Please everyone revise it. If you're having any doubts, then you can clarify. But there shouldn't be any confusion with Ohm's law. Ohm's law is very important law. I told you in the class also, and especially we had separate classes, Memuna. So please revise it, okay? I hope you'll revise.
Yes, ma'am.
Okay. So charge is dq over dt. So what is q? This is c epsilon naught sine omega t. Okay, d is equal d c epsilon naught sine omega t. So when you are differentiating it, omega comes and gets multiplied again. So it is omega c e naught. Then you have sine. Oh, sorry. Now this will be cos. It has been differentiated. So this will now be cos omega t. Okay. Now, see, in this equation, this is the final equation, but there are some slight changes in that will lead us to the main equation. See, I can write this E naught by 1 by omega c cos omega t. Look how I have written. See, class, I have written this part as E naught by 1 by omega c. Class, if you have such a situation, E naught divided by 1 by omega c. So how do you simplify it further? You shift this term to the numerator. That's what we do. If I say 5 by 1 by 5, so my answer will be 25. Because this 5 will go up and it will be 5 into 5 by 1. This is how we use our basic maths. I hope you know. Clear? Yes, no?
Yes, ma'am.
Yes, ma'am.
So that's why this will still be E naught omega c. See, I cannot write it as E naught by omega c. Then it is wrong. But at least I can write it as E naught divided by 1 by omega c. So that when this omega c goes into the numerator, this will be E naught omega c. Means this and this both are the same. Why are we doing this same thing? See, I is equal to E naught divided by XC. It was XL previously. This is XC. And again, how can we write cos omega t? We can write it as sine 90 degree plus pi. Okay. So look. See, current is this. No, I naught is this. See, I naught is this. E naught by XC. Omega sine omega t plus phi. See, this is not phi. This is omega t. This is omega t. Okay. Or let us reverse this only because it is plus. So otherwise it will be confusing. Wait. Sine outside I'm taking so that we get omega t plus pi by 2. So that now we can relate it with the main equation. So see, likewise, what we have done it for the previous circuit, I naught is equal to E naught by XC. Omega t same. Phi naught is equal to pi by 3. Okay, class. So what is it? What are we studying? I am revising this. I is equal to E naught by 1 by omega c. And this 1 by omega c is being written as XC. Now, what is this term XC? What is this problem XC? XE, basically, XC is called as the capacitive reactance. Capacitive reactance is again, it's the resistance offered by the circuit having only inductor. And how can we write XC individually? What is XC equal to? 1 by omega C. Further, if we want to write omega, Memuna, what was the formula of omega in terms of frequency, linear frequency? We have discussed it many times now. Omega's relation with nu, frequency. Yeah, we have done it in today's class also. In the last class also, Zara answered. Look, turn your pages. You must have written it in that part.
Equal to 2 pi.
2 pi nu. Okay. So this will be 1 by, replace omega. This is 2 pi nu C. And what is happening here? Rest of the thing is fine. But what is exactly happening here? Plus pi by 2, and that too in the currents equation. Means current is leading because plus sign is there, something is being added. Current is leading by 90 degrees. In the previous case, voltage was leading. Now current is leading. Current is leading with which value? Current is leading with 90 degree. And this is again important. Now you can write your equation I naught as E naught by XC, or if needed, you can write I RMS is equal to E RMS by XC, like this. What is the full form of RMS, Zara?
Root mean some
Square.
square. Oh.
Root means square. And Memuna, what is the relationship between I RMS and I naught?
It's directly proportional.
Okay, what's the formula? If I want to convert IRMS into I naught, which formula should I use? Something related to root 2, this derivation also we have done. ERMS, IRMS, E naught by root 2. IRMS is equal to I naught by root 2. Didn't we do it? We have done it. Please revise. Please see. Otherwise, your test marks will be hampered, class. You want to score well in the test, in the upcoming test, you should score good. Fine, we are focusing on your exam also. So you should also study. Please study the first portion which is done and this portion. Both the things I will ask you. Otherwise, I'll arrange a separate Viva on Friday where you both are free. At least Friday, no class is there. So it's better, no? It's if we discuss and solve it in the class itself. And whatever things you are not able to answer, that you should remember automatically. Because anything that we are not able to answer, we remember it for a long time. Right? So ERMS's formula, now you will not forget. Both of you. Okay? So you are going to use these formula. So what is XC? XC is basically capacitative reactance. And see, in the formula, yeah, I was saying that XC is equal to 1 by 2 pi nu C, or XC is equal to 1 by omega C. In both the cases, this XC is inversely proportional to frequency. It is inversely proportional to angular frequency. So what kind of graph you will get? You will get a hyperbolic graph because they are inversely proportional like this. And when you have to represent it on the phasor, look, now the current is leading. Voltage is lagging, current is leading. So look, see, current is already at 90 degree and then EMF is at 0 degree. So which is leading? Current is leading. Don't look by the size. This is the amplitude. Look by the angle between them. This is already at 90 degree and this is just started. So EMF is leading in this case. And look, the current is, the current is leading in this case. And look how the current is leading. See, in the previous figure, you must have drawn the arrow on this side. While you are writing, just both of you, just keep on cross-checking it also with the previous one and the first one so that you know what is happening in all these things. So current is there and current will be drawn here. You write down these things. I think this will be it only for today, but you have both of you have to revise it before the next class. Write down. Yeah, if you both have completed, then you can directly leave the class. Let's meet in the next class now. And please revise and come. Okay then. Thank you, Zara and Maimuna.
Thank you.